Hey, integrated 3 students. So I would like to go over sine, cosine, and tangent, and inverse sine, inverse cosine, and inverse tangent, and talk a bit about what they mean, and hopefully kind of visualize what they mean. So first, I'm going to write SOHCAHTOA at the top of this Jamboard. SOHCAHTOA to remind us about what each ratio means, sine, cosine, and tangent. And first, I'm going to draw an angle. So I'm just going to draw 2 lines representing an angle. And we're going to call this angle 40 degrees. So the first thing that I would like you to notice is that if we wanted to make right triangles out of this angle, by drawing a vertical line between both sides of the angle, that as we go out, so if I did what I just did, created a triangle, if I did it at any place along this angle, so right now I'm drawing bigger and bigger right triangles, there's going to be a ratio, a specific relationship between this side of my right triangle and this side of my right triangle. Because the further and further out I go from this angle, you can see that this side length increases, like it's getting higher and higher and higher. But also, this hypotenuse is getting longer as I go farther and farther out from this angle. So there's a very specific relationship. Like if our angle is 40 degrees, for example, the ratio between this side length right here and this hypotenuse will always be the same. And that's what sine is. So the sine of 40 is opposite over hypotenuse, and I'll call this x and y in this case. So x over y. And it turns out that as we go out and draw bigger and bigger right triangles on this 40-degree angle, this side length down here also changes. So if I'm drawing farther and farther out from the 40-degree angle, you can see that this side length, which is the adjacent side, is growing and growing and growing. And the hypotenuse is growing and growing and growing. So this is where cosine comes in. The cosine of 40 degrees is always going to be equal to, we'll call the side z over y. And that ratio, z over y, or the number that you get if you take z and divide it by y, will always be the same for an angle of 40 degrees, no matter what. Same with tangent. Tangent is opposite of our adjacent. In this case, our opposite side, opposite the 40-degree angle, is x, and our adjacent side is z. So our ratio, tangent of 40 degrees, equals x over z. And this will change depending on the degree measure. So if this angle was 50 degrees, you can tell that the angle would change. It'd be a little bit bigger, like it would be a little more opened up. But the ratio between side lengths for sine, cosine, and tangent of 50 degrees would always be the same. Now here's where inverse sine, inverse cosine, and inverse tangent comes in. If we wanted to determine the angle measurement based on the side lengths, that's when we would want to use sine, cosine, and tangent. It's still relying on the same exact relationship. So, for example, I'm going to keep the 40-degree angle. The inverse sine of x over y equals 40 degrees. So this time, we're using the sine inverse and the relationship between the lengths of x and y to determine the angle measurement. Same with cosine. So the cosine inverse of z over y equals 40 degrees. Again, we're using the same relationship. The fact that there is a distinct relationship between the length of z and y for this particular angle to solve for the angle measurement. And same with tangent. The inverse tangent of x over z equals 40 degrees. And you can probably see by looking at these equations side by side that there's a connection. The sine of 40 degrees is equal to x over y. And if we take the inverse sine of x over y, we get 40 degrees. So sine and inverse sine are opposites. One goes in one direction, the other goes in the opposite direction. Same for cosine and tangent.